All right, and we are live. Wow, that's great. Um, First of all, I will stop sharing so you probably see my face now. Um,
Yeah.
Hi, I'm Brian, and welcome to yet another VJUG session. Today we've got not just one, but two people that will help me out, and the fun part is they are in different locations. We have Robert, who is back in the Netherlands, and we have Ray, who is there from New York City. But first, I will tell you something about the Virtual Jug, because the Virtual Jug, as his name already suspects, is a virtual Java user group. We are the first Java user group, probably not the only one anymore, but we are the biggest one. And not to just say we are the greatest, but I think we have the greatest speakers here around online, and that's convenient because, well, the whole environmental thing, we do not have to travel, and that's good, right? But first of all, if you do not have a Jug near you, you can visit us. You can join us, and you still have great content. If you do have a Jug nearby, then still you can join us and enrich yourself with even more and better content. So please follow us. And if you have any questions, go to our Slack channel. Now I will try to share my screen again. And that's also always a good thing. I will ask the guys over there. You'll see my slides, right? Oh, I see Ray nodding yes. So welcome again to the Virtual Jug. Let me just go into this. I'm Brian. I'm a developer advocate for Sneak, and I'm one of the co-leads for the Virtual Jug. Well, I work for a company called Sneak, and I have to name them again because they are, at this point, our main sponsor, because they hooked us up with this Zoom technology, so we are able to broadcast and do webinars for you still free. So thank you then. Today, we have a great session called Surviving Dependency Hell by Ray Tsang. And Ray is a developer advocate, cloud advocate, if I'm not mistaken, for Google. He worked for a lot of companies. He was an engineer for many, many years until back to well, very, very, very long ago. Then we have Robert, and Robert probably is not that well known, well, to some of you probably, but Robert is the chairman of the Apache Maven Foundation, if I'm saying that correctly. He holds the chair, and he is one of the main contributors for Apache Maven. So he is kind of a big shot. Well, if you have any questions, you see their Twitter handles here in the screen, so you can ask them directly, or you can use our Slack channel, as I already told you. We have a Virtual Jug Slack, and please use the live channel session to ask your questions. I will look at the questions, and I will serve them to both Robert and Ray at a, well, convenient time. So that can maybe at the end or maybe in between topics. We'll see how that ends. I will be the one between the viewers and the presenters. If you have any feedback, please ask us, so the Virtual Jug on Twitter, or me personally. If you have good comments, please put them on Twitter, loud, shout it out. If you have bad comments, please come to me personally, and we try to make sure that it will never happen. But first of all, let's have some fun, and I will stop sharing my screen because I think that was my last slide, and I will give the word to both Ray and Robert. Welcome here at the VJUG. I don't know if it's your first session or not, because I'm not that long on the VJUG as a colleague, but I think it's one of the first times we have two people who are presenting.
Cool. Yeah, this will be a nice experience, I guess, with different time zones, etc. This is my second one. What's happening here?
That was my doorbell. Somebody's actually at my door, so
oh,
I have to wait. I'm sorry. Luckily,
pizza.
my wife is home. Yeah, probably
food delivery.
Yeah,
food delivery. Awesome.
So this is my second time. The first time it was in the Netherlands. It was hosted by JPoint, I think. I did a session there about Java modules and Maven. And I think that's already like 2-3 years ago. But that was those were my first experience with the Virtual Jug.
Yeah, I think it's my second time as well, or the third time. I was actually part of the VJUG 24 as well. That was quite quite an experience as well. But yeah, this is gonna be interesting because Robert and I are in physically two different locations. So let's see how technology work.
So let's start.
Yeah.
Yeah.
So let's
do it.
go ahead and share. I'm gonna share my screen, desktop. Oh,
I will just mute, and if another pizza delivery guy will end up, you will not hear it. I promise you.
All right, sounds good. All right, let's get started. Thanks everyone for joining the session. Robert, do you want to go first?
Well, yes, sure. So my name is Robert Scholte, founder of SourceGround, a company here in the Netherlands. And as Brian already told you, I'm also the chairman of the Apache Maven project. And I was a member of the expert group regarding Project Jigsaw. Everybody's using it right now. Well, not sure, but at least I did most of the part of the implementations to support it inside Maven.
Cool. And Ray, I'm a developer advocate at Google for Google Cloud. And I'm also a contributor of a website that we're going to be talking about a little bit, which has some of the Java library best practices that the team here in New York has created. And we're going to go through some of that in relation to surviving dependency hell. If you have any questions, you can find me on Twitter at Satanism. So a lot of the inspiration about this session is because that here at Google, we have some of the client libraries that people can use to connect to our services. And in the past, when you combine a couple of libraries together, then they don't work together, right? And it's being troublesome to kind of figure out what's wrong, why do they have issues, and a lot of these things came from dependency conflicts. And this is where we put together this talk to go through some of the learnings that we have learned, and also whenever we have issues, I kind of ping Robert on direct message on Twitter and say, hey Robert, can you help me out here? What is going on? What are some of the best practices? So hopefully today we're gonna get to see some of the evolution of the best practices that we have come up with, and with a lot of input from Robert as well. So let's see the code. So we have quite a bit of samples written up that we can share. And all of these things are on GitHub. The link's gonna be, on the last slide, I think. But let's see what we got here. I'm gonna zoom in a little bit just so we can all see the code. We have a very simple Maven POM XML here, a very simple application. All I'm doing is pulling in two very unsuspicious dependencies. There's truth, and then there's a translation API, which helps me to translate a sentence or something like that. And if I go to, I wrote this in a test, but usually you put in the source, but let's just, because test is a little bit easier to run. So I wrote this in a test. And here we have a test that says translation API. I'm going to get a service. I'm going to do a translation here from Chinese, which is how are you, from Chinese to English. And we're going to do an assertion with truth. And in the end, it's going to print everything out, right? Everything seems like fine. This thing definitely compiles. There's no syntax error, and we should just be able to run it. So let's give it a try. And this is probably what we all do. It's very simple and straightforward. So everything should work, right? But I guess not. So if I can zoom in somehow, I don't know if this is zoomed in, but we can see here we have no such method error. That can be right. I definitely have the method here. What is going on here?
Right, so it seems like this is code that is being called indirectly, like there's an issue with the transitive dependencies, I guess. Yeah.
So yeah, right. So because preconditions check arguments, I'm not using it directly here,
Nope.
but somebody is calling this from this very deep stack. But I'm not quite sure what is causing it, like where is this being done or what type of issues there are, right? But I think that many people probably see this over and over again. Whenever you see no such method error, no such field error, no class that found error, these are runtime errors that you don't see at compilation time. And these errors are really hard to troubleshoot, or you discover it as you're running the application. And in Java applications, right, we kind of want to trust that when the compiler does its thing, when we have everything packaged up together, everything just works. But these are runtime errors.
Yeah,
Yeah, so I think a lot of this is caused by our dependency problems. So what are some of the ways we can troubleshoot this? Yeah.
So most of the time, what I see a lot of people do is using the Maven dependency tree, and that will show you a long list of all the dependencies as a tree. And sometimes that gives you quite interesting things. So if you just run it by default with the dependency tree, you will see the resolved tree.
Okay, let me try that right now.
Yeah.
Here we go.
Right. So here you see all the dependencies that are actually being used.
Okay.
Right.
So the first level is the truth, and the second level is my Cloud Translate API.
Yes.
And the rest then it goes on deeper.
Yeah, so that's long, right?
Yeah.
So in this case, you won't see any conflicts, but there's another option you can give, and that's the verbose option.
So I do -d verbose equal to true.
Yeah, you can remove that as well, but
oh, just -d verbose.
Yes, that's exactly the same. If you don't give the value, its value will be true.
I didn't know that. Okay. Yeah. So what is the difference in this run? It still shows me all the dependencies.
Yes, but in some cases you see some conflicts, right?
Ah, like right here.
Yeah.
I see. So there's a JUnit here, which we may potentially have two different versions. And then we got auth library omitted. And then so every dependency that has multiple versions potentially in the tree that has multiple versions will see this version omitted for conflict. So what is going on here? Why does these things happen?
Somehow it's always happening with Guava. I don't know why.
Yeah.
But Guava has some kind of bad reputation that they're not always backwards compatible. So even though that we have Guava 21 here, it's probably not backwards compatible with Guava 19. And you may say, okay, we're using major versions, so based on Semver, we're allowed to do that. But in the end, Maven will pick just one of those versions and put it on the class path, right?
Right. So of the two versions, so what dependency conflicts happens when there are potentially multiple versions of the same library that's being transitively dependent on. And we can only choose one of them, right? Maven can only pick one. Why is that? Why can we only have one version?
Well, what Maven does is it's comparing the group ID and artifact ID, and it will pick, there can be only one version of that. And it makes sense, right? Because if you take a look at the class path, it's always the first class that wins. So it goes from the first jar to the next, to the next, to the next. And once it has found its jar class file, that's the one that's being used. So there's no need to have multiple versions of the same jar on your class path. So that's the reason why.
And the way that Maven has chosen as a strategy to resolve this, right? Because every build tool needs to resolve this somehow.
Yeah.
You either fail completely and say can't compile anything, or you have to pick one of these versions. I think Gradle will pick the highest version by default, or the highest in the string value for the version by default.
I think so, yes. Yeah.
But then the Maven picks the nearest one, right?
So the result can be a little bit different based on that. So that's kind of interesting. If you know that some library was built by Gradle and is being used by Maven, you can hit these kinds of dependency conflicts as well, right?
Oh, interesting. So Gradle, because when Gradle produces the artifact, it's depending on the highest version of the transitives. And then when Maven depends on the artifact, it could be using the nearest.
Yeah.
Oh, I see. Yeah, that sounds pretty interesting. So it's probably why also Maven just wants you to declare the artifacts that you want to use, and so you have full control over the versions that you want to use, and that's why Maven always chooses the nearest one, right?
Yes.
Because if you have some dependencies that's deep in the tree, but that's probably newer, but your app actually want to use the older one by choice, you declare that as a direct dependency, and that's going to override other versions as well.
Exactly, yes.
Got it. Yeah. So, but then in this case, Maven does not actually pick the highest one. You mentioned something pretty interesting, which is that Maven doesn't understand sendverb. What does that mean? Yeah.
So Maven isn't really comparing those versions, right? So we already said that it is just picking the nearest version.
Right.
And in the end, yes, you must choose one of the versions, right? So Maven just picks the nearest one, and it doesn't matter about compatibility. That's up to the library builder to do that.
Right. And one of the ways that we can potentially detect this early is something you mentioned to me during our conversations, which is by using enforcer. What does that do?
So in any case, if you want to enforce something like ban specific dependencies or require some, if you have some requirements, the Maven Enforcer plugin is the most powerful plugin you can use. So it comes with a set of default rules, and these are these are two of those rules, but there are a lot of other rules, and you can write your own rules as well. So let's first have a look at these two. So the convergence one, it means that every dependency must have exactly the same version in the whole tree. And that can be quite hard, especially if you have a very deep tree, right?
Mm-hmm. So what this will do is to basically fail the compilation time, fail this build, so that we know that there's these underlying problems that some versions we cannot reconcile, and so you as a developer would really have to figure out which one of the versions you really want to use, right?
Yes, exactly.
So let me give it a try. So I'm gonna add this enforcer, and do it kicks in a compile or a package. I forgot.
I think on validate already.
Validate. Okay.
Yeah.
So I can do Maven validate, and this will kick off the enforcer rule. And there it is. So it tells me that there are all of these dependencies that have multiple versions, and we need to figure out which one to use, right? Even though some of them could be compatible, but Maven does not understand the compatibility between these libraries.
No. Yeah. So if you trust backwards compatibility, you could use the other rule, and that's the require upper bound rule.
Okay, so what does that one do? So convergence means that all the versions have to reconcile. And upper bound will pick the highest version. Is that right?
Yeah. Yes, exactly.
Now, but it's still not based on the semantic versioning, right? It's really just higher in the string comparison.
Yes. Well, it's not really a string comparison. It is aware of digits, etc.
I see.
But,
got it. Yeah. So in this case, we have JSON 2.7 and 2.85, and upper bound will require me to move to 2.8.5 instead of 2.7.
Yes.
Right? Huh. Interesting. But I think this only works though if the libraries are actually backwards compatible, right? So always going to the highest version may not always work for you. And this is actually the source of many of dependency conflicts issue, which is that potentially there's you upgrade to a higher library like from version 1 to 2, and 2 because it's a major version update, so there's usually backwards incompatibility. And so by picking the highest version, it will actually break more things. So we actually run into this a lot. In fact, I'm happy to say that for Guava, Guava 21 and up is actually backwards compatible. So if you're using anything less than Guava 21, please upgrade, because if you use that as a base, then you can be pretty sure that the newer versions will always work with Guava 21. And because of this, we actually came up with quite a few different best practices rule. And this is called JLBP, which is the Google Best Practices for Java Libraries. I can actually go there right now. It's called jlbp.dev. And also all of these is actually on GitHub as well. So you can contribute, you can have comments. And we have quite a few different rules that we wrote down in order to help us to make better libraries for people to use. And hopefully this is also useful for many of the developers because not only does it help you to make better libraries, but also avoid these dependency problems that we see over and over again. So one of the things that we say is to, make transition easy, don't make backwards compatibility, make sure everything's backwards compatible, and maintain a stable API for as long as needed. Okay.
Right. So, but you decided to not use the major and minor versions, right? So Guava is only using major versions.
Technically speaking, Guava is always major versions, and that's why it's always breaking.
Yes.
Until Guava 21. Until Guava 21. Yeah. So Guava 21 and up is definitely better because we do understand this issue. Yeah. Cool. So what are the ways to resolve these dependency problems then? Like I see all of these things here, like we got all these conflicts, right? We need to resolve it somehow.
Yeah.
Let's see. So if I go back to, I got a new computer today, so it's been a little bit difficult for me to get used to it. So what are the 2 ways of reconciling these versions?
Yeah. It's amazing that it is still working, right?
Yeah, exactly. You just put Java and Maven on it, everything would just get downloaded.
Out of the box. Cool.
Right. So to get rid of some of these conflicts, then because Maven picks the versions first, nearest first. So the easiest way is by declaring some of these versions directly into your dependency. But also another like this one, right? So JSON is having issues, so we can declare the version I want to use directly in the tree. But simply by doing this is not enough, because the enforcer will still run through the whole thing and still going to validate whether this is the newest version or not. One of the ways to kind of to deal with other transitive dependencies that's in the tree is by exclusions. So we should be able to exclude things that we don't want and keeping only the things that we want, and so that the enforcer can pass, right? And like Robert said, if we do convergence, that's a lot of work. But if you simply include the highest version, then maybe we don't need to exclude anymore, right? Just because we have the highest version there. Yeah. What are the other ways that we can do this? Because by doing this dependency exclusion and also declaring these versions is a lot of work, right?
Yeah, absolutely.
Because what if there are exclusions that we missed or there are new dependencies?
Right. In general, what you need to do is always specify your direct dependencies here. But all your indirect dependencies, you can use dependency management, right?
Okay. What is that, and what does that do?
So dependency management is something you can add just to the pump file, and in the end, it is just a lookup table. So the first thing that Maven does is when it hits some kind of dependency, it will look if the dependency is managed, and it can pick up that version. So you don't need to specify your versions directly in your normal dependencies, but you can manage it.
So for example, for JSON, like if I don't want to directly declare my dependency here because I'm not directly using JSON, but I just want to overwrite the version of JSON that's being transitively dependent on, then I can add this dependency management section. And then here's the dependency, and here's the version 285, right? Cool. And what this will do is that if I go into my example here, example 3B dep management, and if I say Maven dependency tree, should I do verbose? Let's try verbose as well.
Yeah.
Okay. And then if I see JSON, there it is, right? So this transitive dependency was using 2.7, but because we added it into the dependency management section, it's gonna do the lookup table, it's going to find this entry, and that's the version that we're going to use.
Right.
Okay.
So the funny thing is, it is really just a lookup table. So you can add even non-existing dependencies inside of it. Maven won't care.
Really?
So yes. And the scary part is you can also add snapshot versions here, and it won't be recognized.
So like this sometimes is X. Whoops.
Yeah.
Like this actually works.
Yeah, this works. Yeah.
Interesting. But that's fine though, right?
Yeah,
because we're
that's
not
fine.
depending on this yet.
Yeah.
Okay. Cool.
Cool.
So I think this should work, right? So we resolve some of the conflicts, and let's go into the next example here. it's suspiciously named misalignment. But let's see why this is the case. So here we are using PubSub, which is our publisher subscriber messaging system. And I have something pretty simple here. Again, I'm just writing a small test. I'm using a publisher. I'm grabbing a client. I'm just gonna publish something into a topic. Hopefully somebody will pick it up. And again, here in the pom.xml, we are doing some of these things to resolve our issues. So this is my simple PubSub dependency tree. I also added something called trace because I want to trace the codes. And then in the plugins, I'm using enforcer. I'm using require upper bound, and I resolve all of my dependency issues here with all the override, so that I'm using the highest version of everything, right? So
awesome.
yeah. So this everything should pass, right? So if I go to 3C, misalignment, if I do validate, ideally everything would just work, right? Yeah, perfect. So enforcer will pass. So this test works too, right? So let's give it a try. Let me see if I can run this PubSub test. And let me just run that one, run the PubSub test and see what happens. Is that the one? Is that the way you run it? Yeah, it's coming.
I think so.
Oh, Robert, what? I did all the best practices here. What is going on?
So what's happening here? Like you're already saying it, it's probably got to do with some misalignments. And I think everybody recognizes that if you're working on a Spring application, you normally have to add every dependency with its version. And it could happen that you missed a couple of those dependencies, whereas you need to be sure that all those versions are in line with each other. So I think that's something that's happening here.
Yeah, so let's see here. So there's something wrong with the gRPC. Some method was not found. So we know for a fact that there's a conflict, but we're not quite sure what that is. And this one in particular is being troublesome to debug. So for example, if we see the dependency tree, there's a lot of things in here. And it's really hard to tell in this case, like what version is actually not right, because there's a lot of stuff in here. Similarly, if we do verbose as well, and we're going to see that all the version has been overwritten, right? There's something omitted, but we have no real thing that's being picked up by the enforcer. What is really happening here, though, is something like this. Let me skip a few things here. I think we talked about these. Yeah. So what happened here is that through PubSub, we have a transitive dependency on gRPC, which is all using version 1.0. However, there was one place where we needed to depend on the upper bound of another library called gRPC stop. So while everything else is depending on the lower version, but upper bound only checks per artifact, right? So in this case, we have a multi-module application. gRPC has multiple modules, and we depended on 1.0 for some of the modules, and then we were depending on 1.10, which is significantly newer on a newer round in another transitive, right? So these two things don't reconcile in a way. Yeah. So that brings us to the next practice, right? I think this is pretty important. If you have a multi-module project, so something like gRPC or something like Netty, or if you are a library creator, you are creating a new library with multiple modules, for people to consume it, they are tightly coupled. So it's much better to produce a bill of material. And how does that work, and what is that?
So in the end, it's a little bit of dependency management, where you specify all your artifacts and all the versions, and they are of course aligned with each other. And in your own project, you can include this single file, and with that, all the versions will be in line with each other.
So let's see if I can find a example of this. So let's see here. I have an example of a dependency management. Oh, sorry. 705A.
That wasn't a POM.
Yeah, exactly. What was that? Oh, I need to CD into it. 5A, 5B. Yeah. And here's the dependency management sections, dependency management. Okay, so what you're saying is for a multi-module, actually, this is not the right one. No. Yeah, I think we have a really good example of this somewhere. Somebody produced it, right?
I would say 4A or not.
4A? Okay, let's see example. Yes, let's go into there. Example 4A. Use the bomb. Okay, yeah. So let me go back to my IDE and let's just see 4A. And here's the bomb. Okay, so gRPC has a bomb. Yeah. And Protobuf has a bomb. Yeah, so basically, if I were to open this up, if I were to go back to Maven Central and see a gRPC bomb, let's see, take a look at what's in there. Mm-hmm. See the POM file, and there it is. Oh, hey, hey, Brian, there's a little snake advertisement here for me.
We are everywhere. I'm sorry.
Nicely timed, nicely timed. All right, cool. So if you're producing a multi-module file project, then for every one of your modules, you should list it in a BOM. And so that when we are trying to consume it, we can use the dependency management import, not only to manage our transitive dependencies, but also to make sure that all of the things that we're using from your project is actually well aligned, right? Because this is basically what happened. We're using gRPC-O in one version, and then we're using gRPC context with a different version, and they don't really match up because they're tightly coupled, and that's when all hell breaks loose. Yeah. But I think there's a little bit more to that if I were to go back to this to the slide. Because BOM is really powerful. What are some of the things we have to watch out for?
So what I saw some people do is just add every dependency in the BOM file, whereas what you should do is only sum up those dependencies that are part of the multi-module project itself. So not the transitive or dependencies, you should not add those.
I see. So for example, if my multi-module project depends on Guava, I don't want to add Guava into my BOM because then my consumer of the BOM would use the same Guava version that the library produces, right? And that's not what everybody wants to do.
No.
Quick question: if BOM is overriding a certain version of the library in the transitive, but I really don't want to use that version, is there a way to override that as well?
In the end, Maven will pick the direct one. So, and there is an order issue with BOM files, right?
Okay.
So it will go from the first to the next to the next. So the first one wins.
I see. So even if if I use the BOM, like different BOMs that manages potentially the same set of dependencies, that should never happen. But if it did, the first one would win, right?
Yeah.
I see. So always the first one win. At the end of the day, you can only have one class in the class path, and that's what Maven tries to do.
Exactly.
Cool. Now for gRPC though, in our special case, there's another really interesting practice that the team has been doing, which is to use use a dependency with a strict range. So for example, here, if I removed this dependency right here, if I remove the gRPC stub, I think that if I go in here and say example 3C misalignment, if I try to Maven compile, Maven package, whatever, let's see what happens. Oh, well, it actually tells me I need to use the highest path, the highest version. But if I done this right, I think it's this one. Well, I don't have this right now, but if I done this right, what this will actually tell you is that, hey, for gRPC 1.10, I can only work with other gRPC modules that's of the same version. So because it's tightly coupled, if you specify the version range, a version range typically is not good for most of the use cases. But if you really want to depend on some other specific version, use the inclusive range like that with just one version in there, then you can basically be guaranteed that this is what is going to be used. And I think that's a really easy way to make sure that your multi-module file works properly with each other.
Yes, I don't think you should do that as a library builder because you kind of piss off probably your application builders. because a lot of them can depend on that specific library, of course. So by doing the strict range, you try to get in control, and you might get less popular.
Yeah, got it. Yeah, so why don't we go back to a few other things that we may have missed on the top here, because
can I ask a question in the meantime?
Yeah, sure.
Yeah, there were some questions, and I can type it up, but maybe you can say it better. There are some people there that are confused what exactly a bomb is.
Okay.
So maybe you can recap that in 2 sentences or something.
No, let's show it again. I think the example was quite good. The what you showed on yes.
Yeah. Okay.
This one.
Yeah.
Yes. So the trick is that you specify just a POM file as you usually do, and here you add in the dependency management. You sum up all the dependencies that are part of this multi-module project. And as you can see, they all have exactly the same version. And because of this, you can you only have to add this file, this POM file, once in your project, and based on that, you don't have to worry about any versions anymore.
Right. So and specifically, the packaging has to be a POM as well. So it's not a jar packaging or any other packaging. It's a packaging is POM. And then when I want to consume it, this is the way I can consume it. So here's the example of something that actually works. So here we're using the PubSub library again, but for gRPC version, we're going to use the BOM to override it. And the trick here is to make sure that you import the BOM also in a dependency management section, and then you declare the BOM dependency as a dependency here. But the most important step here is to make sure that the scope is import.
Yeah.
Yeah. So if the scope is not import, it doesn't do anything, right? Yeah.
No, because otherwise it would try to just pick up all the direct dependencies, but they are not there, right?
Right.
And that doesn't make sense. So you must use this magic scope.
Code import. And then what happens is once you have this scope code import, then if we use if we go back here and try to do the dependency tree, what this will do is to make sure that, in our case, because we're overriding the gRPC version using the BOM, so we're dependency importing whatever versions that this BOM specifies. So it's saying that for all of these artifacts, gRPC auth, gRPC benchmark, gRPC context, for all of these artifacts, we need to use 1.24. So here, even though we don't have a direct dependency on any gRPC libraries, but there's transitives, and these transitives will be going back there to see which version of gRPC should I be using for all of their artifacts. And then if I want to show the dependency tree, and if we see all of the gRPC artifacts, now they are all using the 1.23 version, right? And this is the very, very easy way to upgrade the entire set of libraries, right? So not only do we avoid dependency misalignment issues, but say right now we're using 1.23. If one day we want to upgrade everything to 1.24, then all we need to do is go to the BOM, change it to the newer version, and then we can do the compile. We can do the dependency tree again. Oh, let's see here, package. Am I in the right direction? Yeah, I think so. Am I? Oh no, I mean, I'm in the wrong one. So it's yeah, 3. What is that? We need to go to 3D alignment, and then let's do a package again. Yeah, and then dependency tree. As you can see, my new computer. Yeah, so just by changing the dependency import, now we have 1.24 instead of 1.23. This is much, much better than specifying individual versions yourself, even for direct dependencies too, in my mind. Yeah.
Yeah. Thanks. So this is also.
I think this is a great example. Thank you.
Yeah, and I think this is a good thing to that libraries builders should provide. So if you have some sets of dependencies that should have exactly the same versions, please ask if they can provide a BOM as well.
Yeah, yeah. So on our side, on Google side, we have produced bombs now for many of the things, because the gRPC misalignment happens quite often actually, or netty misalignment. So so for gRPC, we now have a bill of material. For our client libraries, we also have a bill of material, so that you don't accidentally mix different misaligned versions together. So whenever possible, as a library consumer, please use the bomb. Whenever possible, as a library producer, please produce the bomb as well. And this is one of the best practices that we have written down. Okay,
Yeah,
cool. So let's see, bomb should not overreach. Okay, so I think there's another pretty bad example that I can show. Here we have another suspiciously named thing called clash. Okay, so let me open up the pom.xml again, and we'll see what's gonna happen here. All right, so again, we're using all the best practices that we talk about. We have the enforcer rule, we're doing require upper bound, we're using dependency management to manage everything for me. gRPC, and potentially should be using the bomb, but let's say we did. And then and here we have two unsuspicious client libraries that we're putting together. Again, if you're using the bomb, you should just use that instead, in which case you don't have these intermixed libraries versions that don't work together. But let's see what happens here. We have a little test. Do I have a test? Yeah, I do have a test. Another example here. I'm gonna try to run the test and see if that works. Yeah, it's gonna download, and voila, we have yet another issue.
Cool.
Yes, and this particular issue is also, this is the other thing that you have to look for is actually this. What happened for this one is that if we go to dependency tree, we should have all the versions aligned. Everything should have the same version, like gRPC is perfectly fine. All the client library versions are actually okay. Now there's only one thing here that was really annoying, and I think that was actually, we have something called Java JDK 5 or something like that. Oh, let me see here, great.
And you should use the import one, right?
Yeah, there we go. So if we look for Guava, because usually it happens in Guava. If we look in Guava, we have the Guava classes, but we also have the JDK 5 one. And that's of a different artifact ID, right?
But the same classes, right?
But with the same classes, that's correct.
Yeah.
So in this case, Guava JDK 5 artifact has the same classes that's also defined in the Guava artifact. And this is one of the practices that we definitely do not recommend. We stopped doing this as well. Basically in Maven, if there are different artifacts, different coordinates, they have to use, they cannot have the overlapping classes, right?
Right.
So that's one of the rules that we have as well. Two artifacts should never have overlapping classes. But how do we detect this? Like how as a library producer or how as a consumer can I actually prevent this from happening on my application in the first place?
Well, it is like one of the first slides we showed you, that this sounds like something you want to enforce in the beginning, right? You want to be sure that there are no duplicate classes. And there is a rule for that. It's not maintained by the Maven team, but it is maintained by Mojo House.
Mojo House.
Yeah.
And it's actually called ban duplicate classes.
Yeah.
That's a great name. Okay. So we have the link in the slide, and we can go there.
Yeah.
And what does that do? So we're using enforcer, but it looks like a lot I need to add. What does this do?
Right. So you always need to add an execution block because it is not part of the default lifecycle. Okay. And that means you also need to specify the goal that needs to be executed. Well, in this case, there's only one important goal, and that's enforce. And then there's a little bit of configuration you need to add.
Okay, so let me give it a try. So here we have the dependency management, and here's my enforcer. I'm gonna go ahead and add this execution for banning duplicate classes. This is gonna be very useful. Everyone should be doing this. And then what is this extra dependency for?
Right. So these I talked about writing your own enforcer rules. So this jar file contains all those custom-made enforcer rules.
Okay, so this one actually has the ban dependency enforcer rule.
Yes, and you need to add it to the plugin and not to your project.
Aha, so add it to the plugin, but not the project. And now if I want to try to run this again, Maven validate, and see what happens. Aha. Awesome. So what happened is that the enforcer rule has detected duplicate classes in your translated dependencies or all of your dependencies, and it failed. And what it showed is all the classes that's actually duplicated, literally all of them.
All of them, yes.
Yeah, but I think somewhere in the top, it tells you which artifacts are
Yeah.
causing these, right?
Yes, yes, so, the first lines.
If only I can find that first line. Yeah, 20-second delay, or right here. Oh, I'm so close. Oh,
there
no.
is. Oh, no, not yet. No, you're still doing the dependency tree.
Really? What is going on? I'm just going to rerun this whole thing and do a less. That's probably the best way to do it. There we go.
There we go. Found in, and there we have those jars files.
There we go. Found in. Yeah, so all of these duplicate classes are found in these two jars, and you should probably get rid of it.
Yeah.
Right.
And this kind of makes sense because the Java modular system has exactly the same rules that classes and packages should be unique within a jar file.
Right. Yep.
So,
yep.
Totally makes sense.
So we also have a rule for that, which is that a unique package should only be in a single Java module because you can't have package clashes between modules, right?
Right.
Yeah. So that's super useful. Another thing that we found out is, of course, we may want to make sure that we are only depending on dependencies that we actually need to use. Because sometimes, in a dependency tree, in a direct dependency, we depend on a bunch of things, but we don't actually know we're using all of it, right? And the more dependencies that we have, the more likely that the consumer of the library is going to run into issues. So how do we actually detect some of these dependencies that we don't actually want?
There's this dependency plugin. We already use the tree goal, but there's also another goal, and that's called analyze.
Okay.
And if you run that one,
dependency analyze, yeah.
Yes. So this will give you a list of. Oh, you're still using the duplicate classes.
Yeah. So we still have the duplicate classes, but then when you do analyze, what will you do if I actually have problems?
Right. What you see are the used and undefined dependencies and unused defined dependencies. So it recognizes dependencies that are not useful anymore or that are being used by your code, but are actually pulled in as a transitive dependency. And the best practice is to always add those dependencies to your POM file.
For the ones that you're actually using directly, you should POM, right?
Yeah.
And for the ones that you're not using, you should remove it. And dependency analyze will help you to find these issues. Oh, looks like it's pretty clean on some of my POMs. Cool. So that's not too bad. Yeah. So one of the things, though, is that some of these issues are really, really hard to troubleshoot. So for example, the issue I showed earlier with the version misalignment, with the dependency tree that's pretty large, it's almost impossible to go in and kind of figure out, oh yeah, that dependency is misaligned, right? It's really difficult to do. The other thing is that if you have duplicate classes, right, if you run the plugin, that's great, you can find it. But if all else fails, if you have just these weird runtime errors, what you can do is to add a linkage checker. And this is one of the new tool that Google has created by the team here in New York, by the engineering team here, because this is such a big problem that we thought we need a better solution. So what you can do is that this is actually an enforcer rule as well. And this is a custom enforcer rule that Robert has spoke about. So for that reason, you need to add the dependency section here. And then you can add an execution to run this tool. And what this will do is to do a static analysis on your application to make sure that all of the reachable code actually calls methods that's actually found in the class path, as opposed to missing because of a dependency conflict. Yeah, especially through the transitives. So this is actually a really, really nice tool. If all things else fails, that's one thing that you can add to your tool bag so that you can determine some of these issues really, really easily. Okay. Let's go back to one of the things that we missed, and that's pretty important. Which is one thing that we did not talk about is shading, right? Because this always come up. Yeah, this always come up. Like, hey, if I have like multiple versions of my app of the libraries, if I really can choose, or or if especially if it is in the system class path, right? If you're using something like Hadoop or Spark, and they are using a really old version of Guava that would in the system class path, and that will always conflict with your runtime application. What do you do? Like, what are some of the practices here?
Right. So in case one of those things didn't work where we talked about, well, the last solution is probably shading. And shading means that you are going to include all those classes inside your own jar, and you can relocate them. And relocate means that you give them a different package. And with that, you won't have any collisions anymore on those classes.
I see. So for example, for Guava, I can shade Guava in my own class, in my own library. However, when you shade, you don't want to keep the same Guava package names because if you did, it will conflict with others, right?
Exactly, yeah.
So it goes back to the rule that every artifact should have its own namespace, its own package. It should not have overlapping classes. But what about class loading though? Because that's another popular solution that people propose.
Yes, so I remember this chat we had, and it depends a little bit on your own system. So for instance, Maven, it uses a lot of class loaders. Could you imagine that there was only one class loader, and that would require that every plugin should use exactly the same versions of all those popular libraries? That's just impossible to do. So what Maven does is that every plugin has its own class loader, and based on that, it is kind of impossible to get this kind of collisions. Especially, it's not possible to have collisions between plugins.
Mm-hmm. Yeah, but it really depends on the app, right? Because if you're running a single app, it's almost it's very hard for you to actually use different class loaders for different parts of your app. A lot of people talk about OSGI. I mean, yeah, that could be a solution, but I don't know who uses OSGI these days anymore. And also there are other issues with class loading with like static references and stuff like that. So be careful. One of the last thing though is one of the best practices, of course, to keep dependencies up to date. But yeah, one of the did I just go to sleep? No. One of the last thing, if I go back to the dependency problem, is that let me get out of this. Right, we talk about using the bomb, right? And we should use the bomb everywhere. That's my thought. And when we do the dependency management, like this one before, what we say dep management, right? In your app, you can also use dep dependency management to manage the transitives, right? And as far as we're concerned, this app is going to be fine because we resolve all the dependency problems to the dependency management section. Now, here's the one thing that you really have to watch out for, which is that when I build this app, when I build this library, when I publish it to Maven Central for other people to consume, when they consume this app, the question is, what versions of my transitive dependencies will they actually be using? And this is an issue that I didn't realize until recently. So for example, here I have something that I'm going to do a dependency on the example number 3, which is importing all the dependency versions from dep management section. And then I'm going to run an enforcer on it, right? Because in the example here, in example 3, all the versions are aligned, right? So if I go back to example 3b here, if I do a package, all the examples are aligned, everything works fine. Yeah, right. Everything is fine. And if I do a Maven install, now I can use this dependency somewhere, like as a transitive, as a direct dependency somewhere. And if I go back to my example bomb issues right here, which I'm just gonna depend on that thing that I think everything's fine, and I'm gonna run an enforcer on it with the required upper bound. Okay, and ideally, everything here should just work because the library obviously works. But let's see what happens then. Ooh. I think this is just it's not installed. So I need to do so this is the annoying part. I need to install the Maven the parent
as well. Yes.
How do I do the not recurse?
What? Only one?
Session.
Yes.
Yeah, there we go. Yeah. Okay. So, and when I go into the bomb issue here and see a package again. Yeah. So I'm depending on a library that has dependency management, but as you can see here, all the transitives are still different. This is still actually broken. And this is one of the biggest issues that I see so far that I really don't know of a better solution right now, except for two things. One is that if your library uses dependency management to build, just remember whatever version that you use to build it and test may not actually be consumed by the consumer. And the only way for this to be consumed is by also importing this as the bomb. And you can do something like this, dependency. And then you put these three lines, you put these lines here. And then you have to do a scope of import, right? And this is the only way that you can also use the same transitive dependencies that you use to produce your library. And this is probably the hardest issue that I've seen so far. So even if you apply all of the best practices, when people are using your library, you could still have some issues. Yeah.
If you've got the type, of course.
Yeah. So that brings me to the last point, which is that I learned this from Code 1 last year from another attendee who showed me something pretty cool. And however, the plugin that he showed me was a little outdated. So I added something myself, which is called the flatten plugin. So there's a way in Maven for you to flatten all the dependency into direct dependencies so that you can use the same versions that you use in the dependency management section. And I have a pull request open to do exactly that. In addition to a plugin called Flatten Maven plugin, the PR is still being reviewed for a while now. But what this will do is to basically produce a flattened dependency tree so that even if you're using dependency management to build your application, your consumers would also be able to depend on the same version that you used to build, right? So it's something that I think I hope that we can, take a more look into. And I know that Robert, you're working on something pretty similar, right, for the new Maven stuff?
Oh yes. So I did the demo during Oracle Code 1, and we're working on it's called a build consumer process, and what it means is that the POM file you have on your local system will be a little bit different from the one that's being uploaded. So right now, it is always exactly the same, which is kind of cool because now it is very predictable. There's no magic, but we discovered that the current model version of the POM is just kind of outdated, and especially with Spring Boot, it is asking a lot from Maven. So we need to work on new specifications of the POM file. But it will only work if we can transform it back into a model 4.0 as we know it right now. So we can, with this, we can improve the POM file and backport it to 4.0 and upload that to Maven Central, so everybody can still use those projects, those jars.
So basically, you have a build POM as you have today, and then when you push it to Maven Central, it will be somehow flattened or with the right versions of everything.
Yes, we still don't know what we're going to upload. The only thing I'm working on right now is that we're going to change the POM file between the one you're having on your local system and the one that's being uploaded. And with Maven 4, we're going to do some dramatic changes to those files.
Yeah, cool.
Yeah.
So if you're interested in the flatten plugin, check out my pull request. What this will do is
click
to
on it. We should motivate people to like that pull request, right?
Yeah, please like it if it if it will help you solve your problems, because this is the hidden issue that a lot of people don't realize, and we could all be running the wrong versions of the transitive dependencies today that you never tested with before. So it's a pretty dangerous thing. In bonus, we talk about dependency analyze. And Robert, I think you released Maven 3.6.2 recently, right?
Yeah, like a month ago, and it contains one of your brilliant pull requests, right? So one of the issues we had is that with the enforce rule, it didn't recognize the wildcard exclusions. So wildcard exclusions means that you're going to change,
something like this to exclusions. Yeah, so we can do group ID.
Group ID, yeah.
So there's an easy way now to really just exclude everything.
Yeah. So this already worked for Maven, but if you were using it combined with an enforcer rule, the enforcer rule just didn't understand this, and now it does.
Yeah, I think it took us about a very, very long time to troubleshoot that issue. Very long time. And what it came down to was a to-do line that simply said, we need to think about what to do with wildcard. Yeah, so that all took a while. Anyways, I think our time is pretty much up.
Yeah. So
let's
see if there are questions.
Yeah.
Well, not that many. I already first of all, somebody mentioned that the transitive dependency fix was really cool, and so I think a lot of people learned something. I'm now putting the pull request URL up in the Slack channel so everybody can look at it and click on it. The only thing I want to know, Robert, how many people currently are working on Maven?
Well, I could ask you if you could guess, but I know you know about the answer. So if you take a look at Maven, it is used by about 60 to 80% of all the Java projects, Java developers. So it depends a little bit on how you ask your question. If you say, what's your primary build tool, then it's probably close to 60%. If you ask people, have you ever used Maven, 80% will probably say yes. And if you take a look at Maven, it contains like about 90 to 100 projects. So Maven itself is just one, but we're also developing like 40 to 50 plugins, and we have all kinds of libraries that are there to support, for instance, transportation, source control management, whatever that's related to Maven. In the end, there are like 5 to 10 active volunteers. So we're talking about volunteers. There's no company behind Maven. So these are people that have to work just during the day to get their money, and in the evenings and weekends, they want to spend their time on Maven to improve it a lot.
So that means that it's heavily used, and there are only a handful of people that actively maintain it, which is
so that's kind of a risk. So we're always looking for new committers and contributors. So one of the things we did is we introduced something that's called Up for Grabs. And Up for Grabs is a label we added to our Jiras. And these are actually kind of simple Java puzzles. Quite often they are not even related to Maven. And they should be quite easy to pick up, and it will try to help you understand how to contribute to the open source project. And if we see that you are actually understanding Maven and how it all works, you could become a committer as well, and maybe in the end become a chairman just like me. Yeah, why not?
All right. I want to thank you. I want to thank you both for this great session. I mean, this is the second time I saw it. I saw it on Code One for the first time, and I still am amazed that there are so many things I didn't know about Maven, how to use it, and how to help you with things that actually are quite common. So both Robert and Ray, I want to thank you for doing this, and I think it was great to have it from 3 different locations, me, Robert, and Ray in 3 physically different locations, and making sure that it actually worked. And well, I'm proud. I'm very glad, and I hope you had fun.
Oh, absolutely. And we're going to do it again, of course.
Yeah.
I think first time we'll be in the Netherlands, I guess, Ray?
Yes, that's right. We're gonna be at JFall in a couple of weeks. So yeah, look forward to meeting other people there. Yeah. So thank you very much for doing this.
Thank you all.
All right. Then I will. If you can stop sharing, Ray, that would be the easy one. All right, great. Thank you all for watching this this session. This session will be directly live available on the website and on the YouTube channel. If you have any more questions, feel free to put them in the Slack channel. I will ask Ray to publish the slides somewhere. So don't worry, we will get there. Thank you for watching, and have a great evening or afternoon. Depends completely on where you are. Bye bye. See you later.